Nothing would stand out to tell us this, but our next factoring problem is probably one of the more extensive problems we're going to see this entire semester. All it's again going to tell us is factor completely, which can mean a whole lot of different things. First thing we should always look for, the greatest common factor. There will be a greatest common factor here. And this is another one where it takes a certain degree of guessing check. I can see 2 goes into everything. There's 4. Yep, 4 will go into everything. What about 6? 6 won't go into 40. Does 8? Nope, 8 won't go into 76. After a little bit of guessing check, 4x, our smallest exponent, ends up being our greatest common factor. When I factor it out, I get a 6x squared. I get minus 19x. I get plus 10. Now again, that's just my GCF. That GCF of 4x is going to be sitting in front for the entire rest of the problem. Because we no longer have any GCF and because we have that number larger than 1 in front of my x squared, I'm going to need to use that whole divide and conquer method, that factor by grouping, that AC method, just to get through the rest of this problem. Remember, A is 6 times C is 10. 6 times 10 is 60. Let's make ourselves a table. 1 times itself. 2 goes into it 30 times. 3 goes into it 20 times. 4 goes into it 15 times. 5 goes into it 12 times. 6 goes into it 10 times. 7 won't go into it. 8 won't go into it. 9 won't go into it. 10 will. But again, this is probably as large a table. As soon as you start noticing you aren't skipping very many, but again, just because it's a larger number doesn't mean it's a larger table. If you were to ask what's the table for 61, 61 is prime. It's 1 times itself. So just because it's a larger number doesn't mean it's going to be a larger table. Even a number like 62 is only going to have 2 times 1 itself and 2 times 31. Just because it's a larger number doesn't mean a larger table, but same rules apply. Take that plus, they're going to be the same sign, the 2 middle factors, so add these together. 61, 32, 23, 19, which you can see is our pair. 17 and 16 we won't even care about. Remember what we wanted to do was GCF sit in front. The first term, unaffected. The constant, unaffected. What we do with that 4 and 15 is just like FOIL backwards, where the last step in FOIL is to combine the 2 middle terms to get the middle coefficient. Here we split it up using those 2 numbers. And in this case, to control our signs, negative 4x and negative 15x. You see how those combine to be our negative 19? Those are the 2 numbers that when we FOIL later will be our middle 2 numbers. Now, our 4x is going to be sitting in front of the entire rest of the problem. And make sure you put it in Math Excel. It's one of the most common mistakes to forget. Factor by grouping. Look at those first 2. My GCF is going to be 2x. When I factor it out, I get 3x minus 2. See how when we say 2x times 3x is 6x squared? You see how when we say 2x times negative 2 is a negative 4x? Again, I'm factoring out that GCF. Up here, once again, when I have that negative GCF, I'm going to have a negative greatest common factor. So when I see a negative 5 in common, factor it out, I end up with a positive 3x and a negative 2. Now once again, try not to get confused with the parentheses. If I distribute this just on the right side, negative 5 times 3x squared is negative 15x. Negative 5 times negative 2 is a positive 10. I'm factoring out that greatest common factor and controlling the signs because it was a negative leading coefficient. Once again, we see that common 3x minus 2. Coincidental that it was almost the same as the last problem. They are what they are. 4x still sitting in front. 3x minus 2, greatest common binomial. Left with 2x minus 5. Here's my factor form. Once again, might not appear like it, but this is probably one of the more extensive problems, more steps and more techniques than of any problem we're going to be used throughout the rest of the semester.